A couple of modules ago, we've seen that as soon as mountains grow, erosion is activated. In general, the higher the relief, the stronger will be the effects of erosion. Erosion is the source of the terrestrial sediments. The type and amount of sediment eventually being delivered to the sedimentary bases onshore and offshore will depend in a significant way from the type and amount of sediments produced in the source area. How sediments are then produced? What will be their grain size and composition? What are controlling processes? These are the issues we want to address in this module. A very common form of erosion is physical or mechanic weathering, which implies that rocks and the mountains are crushed, resulting in smaller blocks. We can mention two important processes. A very powerful mechanism is thermal expansion. Daily temperature variation in the mountains can be very high, possibly up to 20 degrees. Rocks will expand and contract and consequently break. Rocks can also break because of the expansion associated with freezing of water percolating in cracks inside the rock. As you know, ice has a larger volume than water and causes then widespread fracturing. These processes in the mountains are very effective because rocks typically have widespread discontinuities caused by layering or tectonic fracturing. Fractured blocks will fall down. Walking along the foot of the mountains, you can see easily the results of intense mechanical weathering, huge masses of rocks. Interesting to observe that you will find the largest blocks at the bottom of the scree. Rocks can also be eroded by chemical processes, essentially driven by water. Simple examples are oxidation of iron-rich rocks and the dissolution of carbonates. The latter can cause the formation of large caves and tunnels in the subsurface. These are called karst systems. A widespread phenomenon and one of great importance is erosion is the chemical weathering of minerals such as feldspars, which are very common. For instance, in granites and various types of sandstones. The CO2 contained in the rainwater will react with the feldspars, creating clay minerals, typically rich in aluminium and various ions, such as potassium, which is then dissolved in water. Note that because feldspars and micas are weathered away, also the granite will fall apart, leaving quartz grains, clay minerals and ions, which are then transported away by waters. In the picture, you see the results of chemical weathering. Waters and rivers have no coarse grains. All is dissolved and brought in solution to the valleys. Very different from rivers where mechanic erosion is dominating. Weathering, very different processes leading to very different types of erosional products. In the plot, you see that temperatures and precipitations control the type of weathering occur in a specific region. Warm and wet domains are ideal for chemical reactions. Dry and cold mountains, on the contrary, will be dominated by mechanical erosion. When talking about climate change, we've seen that temperatures and precipitation have varied significantly during the history of the Earth. This suggests that also the type and amount of sediments produced in an area can also change because of climate. If, for instance, climate becomes warmer and wetter, a given region will cease producing coarse-grained sediments with various minerals and will start instead delivering sediments which are clay-rich and with little feldspars and micas. Indeed, very important modifications.